In the last video, we talked about vision, and this time we're going to talk about the other senses, the other ways in which we can gather information from the environment, send it to the brain so it can be interpreted. First, we have vision. We talked about that in the last video, but we also have the sense to be able to hear things in the environment, sense of audition. We have two chemical senses, the sense of smell and the sense of taste, that actually detect chemical molecules. We have the sense of touch, which really consists of several different kinds of receptors. There's a pressure receptor, sense of touch. There's a receptor for heat. There's a receptor for cold. And then there are pain receptors that go into effect when we have some kind of tissue damage. Then we have proprioception, which is basically determines the sense of balance, and it sends information to the brain from other parts of the body. Kinesthesis, and it actually goes to the sensory area in the central fissure that we talked about earlier, and we discussed the brain. Remember the homunculus that sort of shows that information from the tongue goes here, information from the hand goes here. That's information coming from parts of the body, telling us what that part of the body is doing, giving us feedback on that. Then we have the vestibular senses that are located in the inner ear and allow us to detect whether we're moving or not, detect where we are in relation to gravity. All those are very important things that helps us stay in balance. This is the ear, of course, and it's where audition occurs. And information actually comes in. The stimulus for hearing, obviously, is sound pressure waves, or air pressure waves that come into the outer ear, travel to the tympanic membrane or the eardrum, and then cause that to move and vibrate as the sound, simulating the sound pressure waves. Then it goes to the smallest bones in the body, the ossicles, which actually mechanically transfer the information from the eardrum into the beginning of the cochlea, a window there that enters, that moves back and forth and causes chemical fluids in the cochlea to actually vibrate and produce changes that really are simulations of the air pressure waves. Now the cochlea is it's sort of wound up here, and as the information comes in from the round window, it sort of travels through that area and stimulates different parts of the receptor cells that are located in the cochlea. They're hair cells. They're located in something called the organ of Corti, and they're the hair cells, and they actually are stimulated by different frequencies of the information coming in. So if it's a high-pitched tone, it'll stimulate one particular part of the organ of Corti, the hair cells. If it's a low-pitched tone, maximally will stimulate other parts of the organ of Corti in those hair cells. So pitch, or frequency, is actually determined by hair cells located in the cochlea. They're also able to sort of submit volleys of information to allow us to hear the wide range of pitches that we can actually sense. Loudness or the amplitude of the sound waves, are simply the number of hair cells that are stimulated that produce our sense of loudness. So audition has several qualities to it. It has loudness and pitch that are determined in the hair cells in the cochlea on the organ of Corti, and whether they produce the action potentials that travel up to the brain through the auditory nerve. We have also the ability to detect location, and we do that because we have two ears. And if information is coming from this side, it goes to this ear before it goes to the other ear. So the difference in timing of the sound as it reaches both ears, the brain can interpret and give us information about where the sound is coming from. It's much more difficult to detect sound coming from directly in front of you and directly behind you than it is where we get the information from our two ears. Interesting development is the fact that we have the ability to put implants in the cochlea, electronic implants that stimulate the different parts of the cochlea, and thus sort of can be interpreted as sound. In fact, if you put cochlear implants on an infant, they can actually, by the time they grow up, they can actually be able to understand and detect speech very, very well. It's a little bit more difficult to do that with adults, but with infants they can. It's a very expensive operation, and it only helps when you have damage to the inner ear, damage to the cochlea itself. If you have conduction deafness, which is where the information is not getting to the cochlea properly, it doesn't help with it. But it does use stimulation coming from a microphone, not from the outer middle ear, but from a microphone that goes and actually stimulates the cochlea itself, producing action potentials that can be interpreted by the brain as sounds of different pitches. Now we have two chemical senses, the sense of smell and the sense of taste. And the sense of smell is caused by hair receptors that are located at the top of the nose here, really in the olfactory bulb, which is a part of the brain that is sticking out right on the top part of the nose. It is hair cells hanging down. And these different kinds of hair cells can detect different chemical molecules producing different odorants and thus different kinds of smell. We estimate there are 5 million receptors located on the olfactory bulb, and there are probably as many as 1,000 different kinds of receptors that detect different kinds of molecules that have different odorants. So we have a very complex ability to detect the chemicals in the air that produce different kinds of smells. We also have taste, like smell, chemical receptors. In this case, the chemical receptors are located on the tongue, and they're located on taste buds, which, by the way, last a very short time. So the tongue is constantly replacing taste receptors, taste buds. The receptors are located on the taste buds themselves. And as we grow older, the ability to reproduce new taste buds declines, and thus our sense of taste actually declines with aging. Because you must constantly be able to reproduce those taste buds to keep the same level. There are different kinds of receptors located on the taste buds. Receptors that detect salty, that detect sweet, bitter, sour, spicy, and umami, which is actually a savory kind of taste. And the combination of these, we can eat foods that have the taste of both sweet and sour, or spicy and bitter, because as they reach different parts of the tongue, we can have different sensations with the same foods. Proprioception is important for our sense of balance, and there are two kinds of proprioception. One is information that comes from our different parts of our body, from our fingers, from our foot, that go up to the cortex around the central fissure, where last time we showed you the homunculus. So it goes to different places depending on what part of the body is providing that information. That's called kinesthesis, which is sort of telling us what our different parts of the body are doing in relation to each other. And then there's another proprioceptive sense that's located in the inner ear along with the cochlear, and that's the vestibular senses, the semicircular canals and the otolith sacs. Here's a picture of the inner ear, and you can see the cochlear, where we detect sounds, and then we have the semicircular canals, each one in a different axis that tells us where we're moving and in what direction we're moving. And then these little parts here called the otolith sacs, which are actually container-like substance with hair cells located all around it, and it has something like little stones in there. And depending on where your head is in relation to gravity, those stones can fall down and stimulate the hair cells located around the container. So if I move my head from here to here, then the little stones are going to move down and stimulate different hair cells, constantly telling me where my head is located. Now, like I said, these are important for balance, and if you overstimulate them, the semicircular canals and the otolith organs, those little stones are moving all around like riding a roller coaster, sometimes that can create a reaction, which it could be nausea, certainly dizziness, inability to really figure out where we are in terms of balance. So proprioceptive cues, the vestibular senses, tell us where we are in relation to gravity and whether we're moving and in what direction we're moving. Sense of touch, I mentioned there are 4 kinds. There are receptors that receive pressure, receptors that receive information about how hot something is, cold, and then pain. Interesting that they also combinations. Like, for example, if I take 2 small rods, one filled with cold water and one filled with warm water, and that the fluids are traveling through those rods, and I hold it in my fist, I will perceive hot, which is a combination of those 2 receptors being fired. There's also, if I move my hand across a part of the body, stimulating different pressure receptors, that will lead to a sensation of tickling. Combination of different receptors produce different sensations. Pain is an interesting one, because pain, it goes up from the body when it's damaged up to the brain, and they are caused by these small fibers that go into the spinal cord and go directly to the brain. There are also some large fibers that are part of the pain perception, that when they're stimulated, they actually inhibit those small fibers. So we can do things like rubbing a wound, the pain sort of is abated a bit, and that's because the large fibers are inhibiting the small fibers in the sense of pain. Pain is very complex, though, because pain is perceived by the brain depending upon things you've learned. Some people are very highly sensitive to pain, some less so sensitive to pain. Also, pain can be abated by the large fibers, given the fact that, like if you're playing in a football game and you hurt something, you might not really feel that pain because you're really working to do the task at hand until the game is over, then the pain hits. So we've dealt with the senses, how information gets into the brain, and how the brain interprets that information that allows us to do things in the environment. Thank you.